Hi students, this section deals with what is a mineral, and there are literally so many ways to discuss minerals. Minerals, here's the first definition. It's naturally occurring, so that means that it's not going to be something made in a laboratory. That would not be considered a mineral. It's an inorganic solid, meaning organic, meaning it was once living, so this is not, has never been living, has a specific chemical composition, and it has a crystalline structure. So those are the four things that make up a mineral, and we will actually do a lab on minerals, so it'll help you to understand it a little bit better. So the naturally occurring and inorganic, I think you probably understand, and having a definite crystalline structure. This means that it forms some kind of pattern, like a regular pattern within its formation. So some of the patterns could be like diamond shaped, some could be like very square and orderly, some could be interlocking. It doesn't really matter, just as long as it has some kind of pattern in its shape. Minerals also have a specific chemical composition. That means that it can be tested and it's always made up of the same chemical elements. What is a little sticky on this one is that sometimes that chemical composition is within a range, and you'll see feldspar here, and feldspar, this is feldspar over here all the way to feldspar over here, and the difference is in between. This is like, some minerals have a very, very, very specific combination or combination of elements in it, and some minerals have a range. So some of them are maybe a couple different choices of things. Minerals also have slight variations in their compositions, and a lot of times that depends on the temperature at which it was formed. So many minerals make up rocks, and here are the most common 8 that make up different rocks. A lot of minerals form in magma. That means in lava. So it's very, very hot in magma, and you would think that magma is always the same thing, but magma is not. Magma is just whatever melted in there at the time is magma. And so it can be a variety of different things. And as that magma comes up and comes out of the volcano and settles, or down in magma chambers, for example, as it cools down, sometimes it comes like out of a volcano and it's exposed to water or air, and it cools very rapidly. If it cools very rapidly like that, then it's going to form different crystals than if it cools very, very, very slowly. And it would cool very slowly if it came up underneath other magma, so it had to, it was kept very warm, or if it cooled off slowly inside the earth in like a magma chamber. So small crystals form from very fast cooling magma, and large crystals form in slow cooling magma. So there's minerals in different solutions. A solution is take a liquid and add something powdered to it, and you're going to have a solution, dissolve something into it. And so minerals form in different amounts in different liquids, which means if you also evaporate off the liquid, then you can get a mineral or a crystal to come out of that. And that's where like homemade crystal kits come from that you've seen before, or even crystallized candy like rock candy, if you've ever seen that before. They put a string in or a stick, and they let the liquid cool off, and it makes this cool like rock like structure. So in identifying minerals, you have the crystal formation, and you have what's called luster. Luster is how much something is shiny or is dull. And so look at this talc powder. Maybe some people would say that's got some slightly shiny parts. Generally, I think of talc as dull. And this kaolinite, and this is very dull to me. Some things can be very, very shiny to me. Like this rock can have a lot of luster, like this rock salt. Sometimes granite does and looks shiny to me. What's hard about luster is it's kind of up to the person that's looking at it to decide if it's like dull or shiny. For hardness, that one is more concrete. So Friedrich Mohs was a German geologist, and he actually invented this Mohs hardness scale where he took things from the hardest things like a diamond all the way down to the softest, which he found is like talc, and he ranked the hardness. So a diamond is a 10. Very, very hard. Very hard. And all the way down to talc, which you touch that as a rock, and it's actually kind of fun because it almost like can crumble in your hands. Now your fingernail is at a 2.5. So your fingernail can actually scratch and break talc and gypsum, but it can't scratch and break calcite because your fingernail's at 2.5. Calcite is harder. So if you go and take your fingernail and scratch it on calcite, the calcite is actually going to beat up your fingernail rather than your fingernail digging into the calcite. And you can see these different things here, like glass is a 5.5, meaning apatite and fluorite and calcite and gypsum can't even scratch glass. You bring them up to glass and you try and rub them on the glass, and they'll actually just do nothing or break apart. Whereas like feldspar, which is a 6 and glass is a 5.5, feldspar and quartz and topaz are going to be able to scratch the glass. So he made this cool scale, and it's a great way to test minerals to try and decide what it is. And so they actually take the minerals and they scratch them on plates. Cleavage and fracture talk about how the mineral breaks. You can see that this halite, which is a type of salt, you can see it's so cool. It just like breaks in these little like cubes that are kind of held together. Whereas like quartz and flint, they just break in all these random directions. And then there's other minerals that like peel away in these like flat sheets. It's incredibly satisfying and amazing. So they all break in different ways, and that is called their fracture. And halite will always kind of break off in little squares, and quartz and flint will always just break however it breaks. Streak is interesting because if you take a white piece of, like in this one, it would be like porcelain or something like that, a white plate for it to streak on. These two minerals look different from each other, but actually they are both hematite. And there's a lot of ways you could figure that out, but they actually have very similar streak colors. So if you can see, they both have more of a brownish, this one's got a little more red in it, but they both have a brownish streak. What's weird about that is this is a gray rock and it's still having a brownish streak. That's because they're both hematite, so they're going to have similar streaks. Then color is another way you can identify a mineral. And here's a variety of colors. That is pretty easy for you to figure out. Another thing that you can use to identify them is their special properties. This is a cool one. This is calcite, but I don't know. Okay, it says it's Iceland spar. But anyways, this one has a double image, and this one, the effervescence, it starts to dissolve. Some are magnetic, some are iridescent, some will fluoresce under a black light. And that's all we're going to go over today.